Yeah. So hello everyone and welcome to the session. So today we'll discuss week 4 activity and practice questions. So yeah, let's get started. So first of all, am I audible to everyone? Like, can anyone tell me?
Yes, sir.
Yes.
Yeah, thank you. Okay. So I'll share my screen now. Okay. Yeah. So we'll start from like the first activity. So okay. So I'll go like if you are having any problem in this activity like 4.2, you can ask me the question.
So question number
Hello, sir.
4.
Hello, sir.
Yeah.
Sir, I have a conceptual dot in lectures 4.5
Okay. So
timestamp.
okay, we'll go there, but I'll go in a like sequential way.
Okay,
I'll go from okay. So will that be fine for you also?
okay,
Okay.
sir, sure.
So which one? Fourth question.
Yes, sir.
So here you have to calculate the probability such that x is equal to 8 given that x is greater than or equal to 4. So what is the problem in this? Like the numerator would be the intersection of x is equal to 8 and x is equal to greater than 4, and the denominator would be probability of x greater than or equal to 4. So in the numerator, you'll be having probability of x is equal to 8 only, and in the denominator, you'll be having uh, x is equal to 4, greater than 4. So if you'll see this, this is the all the question are based on this given data, right? So in this given data, this is a discrete random variable, right? So
Yes, sir.
discrete random variable would be defined for all those like you can say the point, like it will be defined for wherever there is a jump, right? So at x is equal to 0, there is a jump, right?
Yes, sir.
Again at x is equal to 1 there is a jump, and x is equal to 4 there is a jump, and x is equal to 8 there is a jump. So the all the values are defined for 0, 1, 4, 8, right? So
Yes,
here
sir.
the denominator part would be just x is equal to greater than or equal to 4, means what are the values that are possible. So 4 and 8 is possible, right? So in
Yes.
the denominator, the probability of x is equal to 4 and x is equal to 8, but in the numerator, you'll be having x is equal to 8 only, because 8 x is equal to 8, intersection of x is greater than or equal to 4. That means what? Only 8 will be included, right? So
Yes, sir.
probability of 8 upon probability of 8 plus probability of 4. If you'll calculate, you'll get the value. Have you got the point, or should I write that?
Sir, I understand the question.
Yeah, thank you.
Okay,
Sir,
sir.
here I have one doubt, sir.
Yeah.
Can you go up there? Can you show me that? Yeah,
Yeah.
here in these distributions, the range between 0 to 1, it is mentioning the 0 point, let's assume between 4 to 8. The probability between 4 to 8 is 0.88, or the sum of the previous probabilities is 0.88, sir.
The sum of everything is 0.88 till
Then,
now.
then why are they mentioning between 4 and 8, sir?
See,
Like it needs to be less
okay.
than 8,
Alright.
right, sir?
This is CDF, right? This
Yeah.
is not PDF. So whenever you generally plot the PDF, how generally you write?
The similar doubt I have in lecture slide also, sir, but I am not sure whether I will. If you want, I will share it in screen chat.
Okay. So from 0 to 1, this is 0, right? This is 1.
Yeah.
This is 4, you can say, and this is 8.
Okay.
From 0 to before 0 it was 0, the probability is 0, right?
Yes.
And then again from 0 to 1, there is a sharp jump, and this is 0.29.
Okay.
From 1 to 4, the probability becomes 0.68. Right?
Okay.
From 4 to 8 became 0.88. Why is this? And then after 8 became 1. This is what has been described in the table form, or you can say in the this form has been written. This
Okay.
is how. And but if you will see the probability, what you were saying, probability of 8.
Yeah. Here my question is, if it is cumulative distribution function, it needs for a cumulative distribution function for 4, it needs to be x less than or equals to 4. It means the probabilities before the 4, it needs to be sum, right?
Yeah. So if you are telling
F
fx
of
is
x,
equal to 4,
yeah, it
so
needs
this
to be
is
probability of
x less
x
than
less
equal
than
to.
or equals to 4. Then what is the point here, like mentioning 1 less than or equal to x less than or equal to 4? Why are they mentioning like that? It
Okay,
needs
you
to
are
be
asking.
mentioned like this, right? Why they are mentioning like 1 less than or equal to x less than or equal to 4?
Okay, so you are asking why this is written in the form of. So then how you
Yes.
will write it? So every time you can, then you won't be able to you won't be able to show this in the form of table, or you can, if you will see, this is a this is a way to explain, like if you are having some CDF of equals to 4, like here though it is in the form of discrete, so for this value only it will be described, like for 0.5 sorry, for 0, directly you can say the probability is this minus this one, right, to 0.29. And for all those other, like for probability equals to, when the x equals to 1, so you can directly say 0.68 minus 0.29 is the probability when x is equal to 1, right?
Oh, okay. Like they're not mentioning the probabilities. They're for our reference. If it is x between that, the probability is like that. That's what
Yeah,
they're trying to say. Okay.
yeah, so that you can calculate the other values.
Okay, sir. Thanks.
Excuse me, sir.
Yeah.
Sir, in this question only, like in the lectures, when it comes to integers, then in the lectures it was shown that the probability of integers was 0. I don't understand that part.
What the probability? Your voice was not like clear. Can you repeat that?
Sir, in the lectures it was mentioned that the probability of integers was 0. I don't understand that why the probability of integers was 0.
Those are those, like probability at any particular value will be 0 when that is a case of continuous random variable. But this is a case of discrete, right? Hello. Yeah. See, here it's written discrete random variable.
Yes, sir.
That's why here the probability at some point you can define, like in discrete, how generally you define. In the discrete, you generally have the probability for some probability at all the countable, like these are countable, right? We are
Yes,
having
sir.
0, 1, 4, 8, right? So only 4 points are there, 4 ranges are there. Okay, so for each of the values we can define the probability, like for x is equal to 4, the probability is 0.88 minus 0.68, that is 0.2, right? But if you are having some continuous form of CDF, okay, some this form of CDF, so for each, because it has been defined for all those values, so you can't define for a particular single value, right, for some x. That's why in the continuous form you'll be having probability at some x equal to x equals to 0. Okay, but
Okay,
not in,
sir.
but not for discrete, because discrete is general defined for defined for only countable number of, like you can say there are countable number of ranges, okay, in the discrete. But in the continuous it is very big, that is uncountable, you can say. That's why we generally tell if for a particular value the probability is generally equals to 0 for continuous cases, not for discrete. That's
Okay,
why
sir. Thank you, sir.
yeah.
Hello, sir.
Yeah.
Sir, I have done one activity question. Activity 4.2.
Okay, which one?
Activity 4.2.
Yeah, this is 4.2 only.
Yeah.
Tell me.
Seventh question, the where we have to calculate the probability density function of where it is.
This one.
Yeah, geometric random variable. Yes, sir.
So what's the problem in this?
Sir, I'm not getting right answer.
How generally you write the geometric distribution?
The
Geometric
geometric
distribution.
is one minus sorry, p into one minus p n n minus k k power n to the power n minus k.
Geometric is generally like probability of x greater than, like, after, like, some example you can think of in geometric, like if you are throwing a dice, okay, after how many times you will get some six, okay,
Oh,
after like after three, there's a
three.
probability that you'll get after three term, okay.
Yeah.
So for x is greater than 3, how generally we calculate? So first, if you are not getting
P
p
power yeah one minus p
in the form of k,
square.
something like that, we'll
Yeah,
write,
yeah.
okay.
Yeah, actually, but here I do not get the right answer. How it is calculated the cumulative distribution function for geometric random variable?
So you can write the PDF for geometric distribution,
Okay.
and you just have to do the summation for CDF. This is also a
Okay.
simple form of you can say discrete only, and then you have to
Okay.
do the summation for all.
Okay. So this is I get, and I have also done activity 4.4.
Okay,
Uh,
so we'll
okay.
go there in
So can you
4.0.
solve this question number 7?
Okay, let's see that. What is the normal formula? Can somebody tell me for the geometric distribution for x greater than k?
P p into one minus p
1 minus p to
k
the power
minus one
Power k minus
k,
one.
to
k
k
or
minus
k
one
minus 1.
k minus one.
Okay, so if you'll do the summation, okay, the summation would be what? Generally, the summation of GP is what?
To infinity.
What? Okay, yeah, you can write it directly now. Maybe in the last week you would have known how generally we do the summation. After summing up, we generally get in the form of 1 minus p to the power
Yeah.
k, something like
K.
that, right?
Yeah.
After doing the summation, that is for greater than x, for greater than k. And if you have to calculate generally for the CDF, how generally we calculate? For CDF, we write in the form of
X less than or equals to.
Equal to k.
x less than or equal to k. So that will be
K.
equal to 1 minus probability of x greater than k.
P k.
So that is how we write 1 minus p to the power k. Okay.
Okay.
So this is what.
Okay. Then
So this is not just you have to do the summation, you'll get this one. And this has been taught like 2-3 times in the lecture also. And
okay, sir.
yeah. Have you
Sir,
got the
activity
point?
4.
Whoever was
Yeah.
asking?
Yes, sir.
Yeah.
So can you explain 4.2 का question number 6?
4.2 का question number 6. Okay. What is this? Let a discrete random variable x have a CDF of fx. Assume this is a x minus nu upon nu is then the standard. Okay. Then if fx is the distribution of y, which of the following is true? Fy is the distribution of y. Okay. So just have to write y in the form of x and replace x with y. Yeah. So write x is equal to what? sigma y plus mu.
We have
And
to make function for y as it is x.
you just replace here, you are asking for fy, right?
Yeah, yeah.
Yes,
So
sir.
just replace that x with y. So you can write it. What you can write? Sigma y plus nu. You can write as x.
X in terms of y.
Yeah.
Yeah.
So just
We have
write
to-
wherever you are getting x, you can just write sigma y plus mu. So if you will write sigma into y, sigma this no, not this one, sigma into y plus mu. So this is the correct one, right?
Okay,
Just have
sir.
to replace. Yeah. There is nothing there.
Sir, activity 4.4, question number 2.
Oh, okay, 4.4. But any question from this 4.2?
No, sir, I am done. Anyone else?
Anyone else from 4.2?
Question number 5.
Question number 5, I guess I have discussed. Okay, so I'll go again. Okay, question number 5. Okay, so here is what the CDF. The CDF of a discrete random variable x is given by. Okay, so so for x less than -2, it's 0. So for each point you can know, right? For each, it is a form of discrete. It's already written also, and you can see from the CDF also. So what you can write, you can just write which are the values, what are the range of x. So range of x you can know by plotting the CDF. If you will plot the CDF, so before -2 it was 0, and then from -2 to -1 it is there is a jump, and again from that is 0.15, and again from -2 to 1 there is a jump of, and after the jump it became, the probability became 0.35, and now after 1 to second it became 0.75. Okay, and then after 2 it became 1. So you can see which are the values where there is a jump. So there is a jump at -2. So what are the values that x can take? So x can take -2, right? With probability what? 0.15 minus 0, that is 0.15. So x can take value -1 also, because at -1 there is a jump. So the probability would be 0.35 minus 0.15, that is 0.2, right? And again the probability, there is a jump at 1. So at 1 x can take 1 also, and there is a jump of how much? 0.4. And again there is a jump at 2. So at 2 there is a jump of 0.25, right? These are the probability for x equal to x. Now what you have to calculate?
Now this is discrete. X is discrete now.
Yeah, x is discrete, has been given. It's been given here, discrete random variable.
Okay, right.
So now what you have to do? Now you have to calculate y is equal to what? 2x square plus. Now you have to calculate the range of y. So the range of y are what? Now you'll put the value of x here. So 2,
9.
this is 9, right? Again, if you'll put 1, 3, right?
Yes.
Excuse me.
Yeah.
Again 1 you'll get 3, and 2 you'll get 9.
9.
So you just have to calculate the probability of y equal to y. So y 9 from where we are getting? We are getting from -2. So what is the probability of that -2? That was 0.35, 0.15, right?
Yes, sir.
And similarly for this 9, we were having the probability as 0.25.
We will add both.
Yeah, so you'll add both. So what you'll get? 0.4. 0.3. Yeah, and then for this you'll get 0.6.
Excuse me, sir.
Yeah.
So this P of x equals to x is PMF. Is this PMF?
Where? Here.
Yes, the probability which you have calculated now by subtracting.
Yeah. This one, no? This one.
Yes, sir. Yes, sir.
Yeah. See, PMF is generally what? You know, na PMF. What is PMF or PDF? Or
Sir.
PDF.
Yes, sir. PDF. Yes, sir. The PDF.
Okay, this both are same. Means probability at some particular point. Okay, and CDF, if you have to calculate, you just have to do the summation of this PDF.
Summation. Yes,
Hmm.
sir.
Right. So
PDF,
what you have to do?
PDF and PMF are same, sir.
Yeah. Probability mass function and probability distribution function.
And
Sir, it's look PMF and PDF are not same. It's for continuous variable and discrete variable. If it is from discrete variable, this is called PDF.
Yeah, you can say, yeah, and for continuous PDF is generally like called.
Yes.
But both are having the same function.
Mathematically it is calculated same way.
Yeah.
Okay.
But the naming convention is given for the two different types of variables.
If we are talking about the PDF, then we will be assuming that the variable is continuous variable.
Yeah.
Continuous variable. Yes.
Okay, fine.
So 9 we have got from here and here. That's why we are just doing the summation. So what's the probability that we will get 9? So probability is 0.4. The probability when we are getting 3, y as 3. So we are getting from 0.2 plus 0.4. So we are getting 0.6. Got it?
Yes, sir. Thank you.
Yeah, thank you. And any other question from this point 4.2? My voice is not clear, or what? Somebody selling echo or some sort of things is coming.
No, voice is clear, sir.
Okay, thank
This
you.
is clear, sir.
Clear,
sir.
Okay, so 4.2, you don't have any problem, right? So we'll move to the next one. Is it fine?
Fine, sir.
Okay. So 4.3, do you have any problem? There are only, I guess, two questions are there. So in second question, does anybody have problem?
No, sir.
No, sir.
Can somebody tell me? Excuse me.
But sir, can you repeat question? I could not hear properly.
Yeah, can somebody tell me why second is not correct CDF?
Since it's starting from the bottom again after hitting the top.
So it is because
It's a decreasing function.
It's a discontinuous.
No, it is jump. It is having a jump.
It's jump.
Difference.
It's a mixture.
Point something.
So it's not an increasing function.
It's not continuously increasing.
Yeah, it's not an increasing.
Area is more than 1 here.
Yeah, area can also do. Yeah, correct. Fine. So we'll move to the next one. I guess nobody is having any issue in 4.3. Yeah, so 4.4, somebody was asking which question?
yes,
Sir,
question
I
number
have a doubt
second.
in lecture. Sir, I have a doubt
But
in
question number
lecture.
2.
Okay, I'll go to the lecture also. The second question, which of the
Yes, sir,
following
second.
question can't represent CDF? Just do the, what's the problem in this?
Sir, I have doubt is in the second here is second option is not correct because but if we choose 0 because -2 to 1 is second option 1/3 bracket 0.7 x plus 1.4.
Sir,
Sir,
can you explain this question?
Yeah, you can.
yeah.
And if it's possible to zoom a bit.
What? Zoom, huh? Is it visible now?
Yes, sir.
Yes, sir.
So, so you are having doubt in second, which is not.
Yes, sir.
Okay, the second one can't represent. Okay. See that whether there's a jump or not. This is for the CDF, right? Okay. So there can be many methods to solve this question. One method is you can just calculate the PDF for each point. Like you can just differentiate for each interval. Okay, so you'll get the PDF.
Yeah.
And then you can just calculate the area. And area should be one method. Second method, what you can do? Second method, what if you have to see the CDF is correct or not? Some basic things are f0, like f minus infinity should be 0, so that is fine for each and every cases. F of infinity should be 1, and this function should be increasing, right? Okay, so I guess the second one, if you are having some value between, just put some values between minus, like put 0 here. So at 0 you'll be getting 1.4.
1.4. Yeah, yeah.
But again you will get 0.7.
0.7. Yeah.
So it's not an increasing function, right?
Yeah.
Sir, it is given in the question that all options are non-decreasing functions.
Yeah. So if it is non-increasing function, then it does not represent the CDF. But here it is not correct.
Yeah, that should not.
That is 1.4 by divided by
1.4 divided by 3.
Okay, yeah. It's a divided by 3 is also there, right?
Oh, okay. Yeah. Divided by 3.
So 0 is not. You can check for some other.
But even in the first option also 1.4 by 3 also
Yeah.
is there.
Yeah. That I have seen. Yeah.
And
So
it's also given all
just
the
break through some method, like you can just put some x values and just see that whether it's satisfying all the conditions or not.
So we can integrate into these limits.
What?
So we can integrate this 1 by 3.5 x plus 1.4 into the limit -2 to 1. And if we get sum as 1, the integration equals to 1, then it's a valid CDF.
For CDF, you are telling?
Yes, sir.
I don't think so. For CDF, it will work. For PDF, it will work because the area under PDF is generally 1. But for CDF, it should not work because CDF is a different
different.
For CDF, you have to check this conditions, like both two conditions are already satisfied for each of the 4 options. One condition is that non-decreasing and all, you have to check whether it's a non-decreasing function or not. By integrating, you can't get for CDF.
Yes, sir, it's PDF. Yes, sir.
Yeah,
sorry.
Because CDF always will be having more than 1.
Okay.
So you can just get some, like, just put the value of x or some sort of values between -2 or 1 and 1 and 2, and then check whether what's the value. Or the simple way is to just differentiate this for all the interval, get the PDF, and then calculate the area, and it should be done.
Okay, sir.
Sir, question 3.
Syllabus for quiz 1, 1 to 4 weeks.
What did you tell them how to check, sir? Get the area.
Not get the area, calculate the PDF and then get the area. One method. There are other methods also. Other method is just put some values of x and just check whether all the functions are which of the function is not non-decreasing, or you can say not which of the function is is breaking.
What question is saying that all the functions are non-decreasing functions?
Yeah, it's given to the following.
Contradictory. This is, if it is so.
Yeah.
How can we either this one is correct or that one is correct?
At 2, if you'll put here, if you'll put 2, okay. If you'll put
standard method. What is the standard method to check? Put the values.
Standard method is normally the standard method you have to check the function whether it's a non-decreasing, and here it has been given non-decreasing. You just check the put some values like just put that 1 here. What will the value? If you'll put 1 here, 1.4 plus if we'll put 1 here, so 1.4 plus
all are non-decreasing.
yeah, correct. I'm just checking, just put some, there would be something like there would be some values where it will get what you can say, continuous or some sort of things will be there. That is how you, it's a hit and trial method, nothing you can't do anything in such questions.
Okay.
If we put -2 in second
Answer.
Yeah, what somebody was asking.
-2 in second option, value of x.
If you will put -2 here, what will the value? It will get 0. Okay, yeah, at -2 okay, at -2 0.
Less than -2 is also 0. Greater than -2 is also 0. Up to 1 it is 0.
No. At -2 only it's 0. And
Yeah.
if you increase the value,
Here -2 to 1 is also 0, sir.
no. At x is equal to 0, it's 1.4 upon 3.
Yeah. Up to -2 it is 0.
Yeah, up to -2 it's 0.
After
And
that
then
it
will increase, like you can plot this.
then it is negative. Yeah.
Like for -2, right?
Yes, sir. If it is greater than -2, then it is negative.
So for first fx, I think there is a break from x less than -2 and x lies between -2 to 1. It becomes discrete here.
It goes negative, sir. Right? No.
No, it will not go negative. There will be some discontinuity or some sort of things.
2.2.
Yes, sir. They, at x equals to -2, the value doesn't comes out to be 0.
In the first case, right? That's why it's not.
So that's why it's not a valid series.
Yes, sir, here how option 4 is incorrect.
Okay, how option 4?
So one thing I need to ask here, if the function is a valid PDF, does it implies that it's also a valid CDF?
Okay, if a function is a valid PDF, then
no, it is not necessary. It will be a CDF.
Wait.
And vice versa.
So if you're having some sort of function PDF, so if that is you're telling is a valid, means that is a continuous for all R or whatever the range is has been given. If you have to calculate the CDF is simply the integral of a PDF. So I can't be sure, but it should be like it should be fine, I guess. It should be a valid PDF. If
For first property of PDF, it says that fx is greater than equals to 0, and this means the derivative of an increasing.
Your voice is not clear. Hello.
Yeah. Can you repeat that once again?
So now it's clear.
Yeah. Clear.
Sir, for using the properties of PDF, the first property implies that fx is greater than equals to 0, and this fx is derivative of a CDF. And CDF is an increasing function. If CDF is an increasing function, then only the derivative of CDF, that is fx, that is the PDF, is greater than equals to 0. So if it is an increasing function, this value of this property of CDF is satisfied, is covered in this property of PDF, this property number 1. So can we kind of contrast both of these things, that if it is a valid PDF, then it has almost the chances that it's also a valid CDF?
Yeah, correct. That is what I was telling, but I'm not 100% sure. But yeah, you can say if you are having a valid PDF, you can you'll be getting a valid CDF also.
Okay. So in which case it is can you give any example where the function is valid PDF but it's not a valid CDF?
I need to think for that, but I guess there won't be any cases where you'll like if you are getting a like valid PDF, you'll get a valid CDF also because
Because the
CDF
PDF
is
is one way forward to CDF.
yeah. So CDF is simply the integral part of the PDF. So if you are getting a correct PDF, if you are having a correct PDF, so you'll be having a correct CDF also, right? Because
Yes, sir.
PDF generally satisfying all the properties of the basic probability.
So if
Okay.
PDF is any function, then its integration will always exist.
Yeah.
So I think if it is a valid PDF, then it also satisfies that it's a function is a valid CDF.
Yeah. Correct.
Okay.
I
Okay.
don't think, and I don't think there will be any function or any sort of thing where you'll be
Yes.
having a valid PDF and you'll not get CDF. So every time you'll, if you are having PDF, you'll get CDF, correct CDF. Okay.
Okay, sir.
Yeah.
There is option
Yeah.
4.
Okay. So option 4 you can do like if you are having x, what is the value of x equals to 0, x equals to 0, it is 1. Okay. But I don't think it's a decreasing function, I guess, right? It's not an increasing function.
But in the option they are giving all are non-decreasing. In question.
Okay, all are non-decreasing. No, sorry. Wait, 1 second. How generally you plot e exponentially to the power x?
That one is increasing now. 1/2 into 1 minus e to the power
It
minus.
is-
Then it will be increasing.
And then e to the power minus x, right?
Yeah, it will be increasing.
At x is equal to 0, the value would be 1. And x is equal to infinity, the value would be this one, right? And then we are doing this 1 minus sort of things. So then our plot will get changed. And x is equal to 0 to 0. No, the function is fine. Okay. And
It will be increasing.
Sir, if we plot this function on a graphing calculator, the function won't ever reach 1. So can we say since it never reaches 1, it's not a valid thing?
Okay, all the functions. So if we are putting, yeah, so some of the properties are like, see, the basic 2-3 properties for the CDF to be correct is f of that infinity should be 1 and f of minus infinity should be 0, right?
Yes, sir. For this
thing.
function, f of infinity will never reach 1.
Yeah, so this is the basic thing. This is the two basic, and then you should check for the non-decreasing function. And then after checking these 3 also, if you are getting confused, you can use some method like putting some values, just get some discontinuity thing, or you can just differentiate those and get the PDF and calculate the area if you're getting 1. So those sort of things you can do if you're not able to crack with the help of these 3 things. Okay.
Excuse me, sir.
Yeah.
So one more thing here. So property number 2 of PDF, fx dx when the limit goes to minus infinity to plus infinity equals to 1.
Yeah.
So this, the professor also explained in the lecture that this implies that f of capital F, the CDF of f of infinity minus f of minus infinity equals to 1.
Yeah, correct.
The professor has proved this using this PDF part. So from this also we can say that a valid PDF, if a function is a valid PDF, then it is also a valid CDF because both of the properties are used here in contrast with each other.
Yeah, correct. You are
Actually, we
absolutely
really
correct.
get
So it is
disturbed when we are
100%
discussing
sure,
that
no?
flow.
Yeah.
So when we are discussing the flow of some question, we are getting disturbed with this particular query. Can we discuss that particular question or this query complete and then we can move?
Okay. Yeah, this is done. So let's move to the next one. Yeah, you are also correct. That PDF you are having some part like correct PDF. So
So
it
it's
should be a
always
valid.
true, na, sir? I just
Yeah,
want
yeah.
to ask this. Okay, sir.
Yeah, it's always true. If you are just think of if you are getting something in your mind, like if you are any valid PDF and not getting any valid CDF. I don't think so. There will be any. Because PDF generally satisfy all the properties of basic probability. So I don't think so there will be any function that if you're any function for the PDF it should be it is valid, and for the CDF it's not valid. So I'm not able to collect any of the function. I don't think so there will be any function.
Because sir, in the properties of PDF, all the properties of CDFs are present.
Yeah, fine. Yeah, correct.
Okay, sir.
Yeah, thank you for your. Okay, so which question next? You were asking, somebody was asking. Third one or fourth one? Fourth, huh?
Third.
Okay, third.
Yes, sir.
See, this is a function, this is a continuous random variable, right? So for continuous random variable at any point, we'll be having the probability as 0. Okay. So here you don't have to see the CDF also, PDF, anything.
But if we like substitute that 0 in that equation, 1 minus x the whole square by 2, we don't get 0.
Yeah, so this is not a PDF. This is not PDF. This is CDF now. CDF will not give you the, if you are putting some value in CDF, that value is generally the summation of all the probability till that point. That value is not the probability at that point. See,
okay, sir.
Yeah, have you got the point? Like CDF generally give you the probability till that point. So you will be summing all the PDF till that point. Okay. So like if you're putting x is equal to 0 here, that will give you all the value of probability till x is equal to 0. Okay, it will generally do the summation part and then give you the probability till x is equal to 0. Okay, not exactly x is equal to 0. Exactly at x is equal to 0, if you have to calculate, then calculate for some more value like x plus alpha and calculate for x minus alpha, 0 minus alpha and 0 plus alpha, and then see that if there is a jump or not. There won't be any jump. Okay.
Okay, sir. Thank you.
Yeah.
Question number 7 from the same activity.
Question number 7. So you have to calculate the probability from 0 to 2.5. Okay. And this is the CDF plotted. Okay. So from 2 to 2.5. So what you can do, so that is what generally you have to calculate till 2.5 and then you have to subtract. You have to calculate till 2.5 and then calculate till 0 and then do the sum. Just have to subtract that, right?
So my answer is not matching.
Okay. What's the answer you are getting? 0.35 is the answer here. What's the answer you are getting?
0.5.
So till 0, what's the value? That is, I guess, 0.4, right? And till 2.5, what's the value here? 7.5. 7.5. So you can directly write 0.75 minus 0.4. That is 0.35. 0.35 has been given. Your voice, can you come closer to your mic?
So can you explain this once more, sir? I have found the equation of line for both of the lines, and then I have substituted it like in f of 2.5 minus f of 0.
What's the equation of this line?
So 0.5x.
It's 0.5x.
Yes, sir.
Okay, then if you're put 2.5 in that, 2.5 into, then you'll be getting 0.125. I don't think so. No. This is not point. Okay, so 0.5 you are 0.5x you are telling. This is the equation of line. If you put
no, sir. equation of line is, I think, wrong, sir.
Yeah.
0.5x plus 0.5.
Yeah.
What? X plus
0.5x plus 0.5.
Yeah. This will be the correct equation of the line.
Yeah. So now you're having 0.5x plus 0.5, right?
Yeah.
So put the value as 2.5 here. So now you'll get what? 0.5 plus 2.5 multiplied with 0.5. What's
0.75?
0.125.
And you'll add 0.625 you're getting. Sorry.
Sir, the correct equation of line is 0.5x minus 0.5. Then you will get the correct answer.
Sir, how
can
it is,
can enlarge your note?
Sir, how it is 0.125?
Wait, I'll just write the equation of the line you're, I guess, finding is incorrect. So here, what's the value of 2? Just put what's the equation of that line? y2 minus y1 upon x2 minus x1 is the slope, right?
Yes.
Yeah.
Okay. So here, what you can just consider this as a x line and this as a y line. Okay. So y1 comma y2, what's the point here? We are having 0.5 comma 2, right?
Yes, sir.
And here we are having 3 comma 1. Okay. If you'll do, what's the slope you are getting?
0.5, no?
0.5.
So just tell me the x1 comma x2, x1 comma y1. One was what?
So 2 comma 0.5.
2 comma 0.5, right? And the other was x2 comma y2 was what?
3 comma 1.
Yeah.
3 comma 1. What's the equation of the line? y2 minus y1 equals to m x2, some sort of thing. Okay, wait.
Y minus y1 is equals to y2
Yeah, y minus
1 by into x minus x.
So y minus y1 equals to m
into x minus x.
Right. And the slope you can get directly y2 minus y1, that is 0.5 upon x2, that is 1, right? Just pass this line through any equations. Y minus 0.5 equals to 0.5 x minus 2. So now you'll be having 0.5x minus 1 plus 0.5. So you'll be having 0.35x minus 0.5. This is the correct equation. Similarly, you can find for this equation, or should I find that? For this equation also you can find, if now you are having the equation of this line, just put that 2.5 in spite of x, you'll get one value of y. Similarly, put that value for x equal to 0. Where is that 0? Okay, just find the equation of this line. Here you can write minus 2 comma 0.3 and 2 comma 0.5. Put the value of x here. So
Okay, so now I will try this question once more.
yeah, you
I
can
think
try.
I was mistaken in between the equation of the line.
Yeah.
Okay.
So you can try that, and if you're not getting, you can just post it in the discourse or somewhere.
Okay, sir.
So
Okay.
question 8. Can you do that?
Question 8 is probability of x greater than equal to 1 in the same equation, in the same plot, right? X greater than equal to 1. Okay, so find the value of this one and just subtract it from 1. So if you're getting, for example, I'm telling you, between 0 to 1, the value is between some sort of 0.4, I guess. Now, between 0.4 and 0.5. Okay.
1.9.
What? Okay, so you'll be having 1 as some sort of values between 0.4 to 0.5. For example, I'm taking as 0.45. For example, I'm telling, or 0.41. So just subtract it from 1 and you'll get the value of that. Have you got the point? See, you have to calculate the probability of what? Greater than equal to 1.
Yes,
That
sir.
means you can write it in the form of 1 minus probability of x less than 1.
Yes.
Okay, and this is continuous, so you can write it in the form of this one.
Yes, sir.
So F1 you can calculate, just see this graph, just find the equation of this line, put it the value of 1. So you'll get around, I guess, closer to 0.5, like 0.45 or something like that. Okay.
Yes.
So if you'll write here 1 minus 0.45, you'll get something around 0.55. Not exact, but something around 0.55 you'll get. Okay.
Yes, sir.
Yeah.
Okay, sir.
Anything else from this?
First equation of the line we have to derive and then we put the value, right, sir?
Yeah, or you can say directly, if you have to plot, you can get, see, directly you can say if that is 0.45, we are getting 0.55 also. So I guess that was exact value of 0.45.
Okay.
So exact value you'll be getting after plotting, if you calculate the equation of the line and then put the value of 1, whatever the value you are getting, okay, that is the CDF. CDF means less than equal to that value. And
Yeah.
you have to calculate greater than equal to, so you can just do 1 minus less than equal to, you'll get for greater than equal to 1.
Okay, sir. Thank you.
Yeah. Next one, next question.
Sir, I have a doubt from the lecture.
Okay. 4.3 now.
At no 4.4 itself. What you were
Okay.
discussing right now.
4. This is 4.3 or 4. Okay.
At 28.35.
$28.
28.35, right? So, sir, over here, I was not able to understand this portion. The problem is associated with the notation. The probability of x lesser than -3 is written as f -3.
Yeah.
How will we denote probability of x equals to -3 in terms of f?
Probability of x equal to 3.
Yeah, that's what you see towards here, towards the bottom right of the figure that professor has made.
This one.
Probability x, yes, probability x lesser than 3 is equal to f of -3.
Yeah.
And how will we write probability of x equals to -3 in terms of f?
X is equal to -3 is generally like for the continuous 0, right?
Yes, for continuous it is 0.
Yeah.
But would there be any would there be any depiction in terms of f for x equals to -3 is my question. I understood it is 0, but I'm asking in terms of notation, how will we denote if probability of x lesser than -3 is written as f of
You
-3?
can just write like
What
this.
will be?
You can just, what I feel, you can just write in the form of like this one. If you have to calculate some probability of x is equal to x only. So you can just write in the form of.
So it's the same as, yeah, okay.
You can just write x plus delta, some sort of things, minus fx of x minus some, this value is some positive value plus some smaller values, right? And this, so this, in this way you can write probability of x equal to x, but that is 0 1. If you are asking for notation, you can write it in the form of this, but this value is 0 1 because there won't be any jump, some sharp jump and all. Okay. Excuse me. Yeah, but almost
This
every
as the
time,
notation.
yeah, you can write in the form of, but it's always 0 for continuous because You already know for the, because there are n number of ranges, so for each ranges the value would be 0.
Okay.
There will be like around 20 question, I guess. 18 to 20 question will be there in the quiz one. And the question are like almost from the, you can say, same pattern as assignments, question practice assignments in graded, and some of sort of concept has been taken out from the lectures itself. You won't be facing that much problem in solving the question. I just go through because see, I guess third week is not that difficult. Fourth is also not difficult. So just focus on the first and second is like basic one and more conceptual one. So you can give more time on first and second, third and fourth you can do directly. Like that is what I feel. So let's move to the, okay. So it's done. So 4.4 we were discussing. 4.4 is done, right? Does anybody has problem till 4.4? Any other question if somebody has missed or somebody wants to get clarity on any of the other questions till 4.4? No, right?
Sir, am I audible?
Yeah.
Sir, can you please show me how can I convert the CDF into PDF? Like you can take example from question number 2.
This
Yes,
one,
sir.
right?
Yes, sir. How can I convert this CDF into PDF?
Just differentiate it from like, you just have to
So
differentiate.
Limits will be changed?
No, limit will be same.
Okay, sir.
Just try that some example, some function, and then if you're not getting, you can ask. There are like 2-3 more sessions, right? So just try that more and more like functions, and then you can come. If you're not getting, if you're not able to do that, maybe we can discuss.
Only one person will be more, na, sir? Sunday is the last, no?
There will be session, I guess. Revision session are there.
Revision session will be there, yes.
Like for week 1 and 2 alone, and again for week 3 and 4.
Then what will be in the during the revision session? Other week will content will also be released.
Yeah, it will be released, but yeah, you can focus till the
last time also it we faced a lot of problem. I think at least up to quiz they give 3 or 4 days gap.
See, in the stats too, there are some refreshment, like you can say week where there won't be much, like there won't be new content, only the revising things will happen. Like in week 6, there will be, everything will, there won't be any new concept. So yeah, you'll be having a break week sort of thing.
At least for the exam quiz 1, quiz 2, at least 1 week or 4 days or 3 days must be given, so that should be covered for the revision. That is also time is required.
Yeah, professor is also going to take on, I guess, 27th or 26th before the quiz. So one session. So there are 3-4 more sessions, like I guess.
No, sessions are there, sir. They take the sessions, but what happens is that for that week we go lagging behind, because
yeah, but they'll increase the time. Don't worry about that. They'll, some sort of things will be given, like they'll increase the.
Last time also it happened, na, sir. The design of the course, I think not matching with the. I think.
But again, that is a bit difficult to again, because there are so many courses. Again, if you'll delay 1-2 weeks every time, so it will become.
I'm not delaying, sir. Not delaying. The gap is required, na, sir. That is required.
Yeah, so we'll give you the one gap, like in stats, we'll give you 1 week gap, not gap. So those will be like just the revising.
Sir, they are just giving the sessions, additional sessions. That additional sessions are not sufficient to cover up. I think so. But if it is so, no problem.
So,
Okay, let us
So
proceed.
can I ask the doubt in lecture first, 4.5?
yeah. Yeah.
And at 4.5 at 4.38.
Okay. Yeah. Where is that?
So
4.38,
yeah,
right?
so it is 4.38.
Hmm.
So it is more from a conceptual perspective, how this PDF is coming, probability density function, and the concept of it can go above 2, sorry, above 1 also. I was not able to understand properly, though I heard the lecture a couple of times, but that
Which
concept is not
PDF can
sinking
go?
in.
Which PDF can go
The
above 1?
the probability density function
Hmm.
can go beyond 1 also, as compared to CDF, which just remains till 1. The concept of having the PDF go above 1, I was not able to understand through this particular video at least.
Above 1, I'm also not getting your point. The area
No,
can
the
be 1.
PDF probability density function, so the value that probability density function can take for some interval can be above 1 also.
What value would be? The probability value will be above 1 or what?
Yes, right. Is that rightly
No.
understood, or
When
that is
is
not the case?
it told the probability value can't be above 1 for the PDF for any other, like anything?
Just maybe 5 seconds. Go ahead, 5 seconds. In the example which was shown over here.
Where? This one? Here?
It's not coming over here.
Back or forward?
Yeah,
Should I do?
there was an example where we had the CDF and the PDF. When you opened the lecture, that came across.
Okay, so maybe
Yes,
that.
the professor has mentioned PDF can go beyond 1, but CDF can't go beyond.
So it's like that PDF
Yeah, so
value
over here,
can go
right.
1, but probability can't go 1. Like
Okay.
value of PDF is going 1.
Yes.
Yeah, so this particular thing over here, we see 2. What this 2 means in terms of PDF. Is it the probability of, I mean, again, continuous thing does not exist, but what exactly this means from a PDF standpoint that it is at 2?
Okay, so this is just a uniform distribution and has been defined from 0 to, here it has been defined from 0 to 5. So the probability for at each point is less 1 upon b minus a,
B
right?
minus A, right.
And here the probability has been defined from 0 to 0.5. So the CDF is, the PDF is from 0 to 0.5.
Again, 1 upon B minus A, accordingly, it goes to 2.
Yeah, it goes to 2, but this 2 is not probability.
Yeah, sir. This is PDF. PDF can go beyond 1.
1 second, 1 second. This
The
PDF.
value of the PDF can go beyond 1, but the probability is not at some point. If you calculate the probability, then it will not. It will be less than 1.
Is it a random variable?
Yeah.
But yes, some uniform distribution has been given, right?
The random variable is -1, 0, and 1. That is the values that it is taking. So I want to understand what this 2 means when we are seeing at the PDF. Now we see over here 0, the PDF goes till 2. What exactly that means? What is the interpretation of this PDF when we are seeing this particular graph in terms of the random variable? Understood? Integrate CDF, we will get the PDF.
Yeah, you'll get.
And then we see this particular thing. What exactly is the significance of this particular graph for the random variable -1, 0, 1?
1 second. I have not seen the lecture, but yeah, with the help, like whatever the uniform distribution is a fine distribution, there is no problem in that. But the thing is, you are asking what is this 2 representing?
Correct. What is this 2 representing? If we can get something, then also we can understand how it can go beyond 1. सबसे पहले तो यही समझ में नहीं आ रहा why it is going above 1. And second, what is this particular graph? I mean, we see the graph, it is at 2. What does it mean? Calculation wise, it's okay. We can do that integration, derivation. We will come to the answer, but what does it mean?
Okay. The area we are getting 1, that is fine. Every time for the probability density function, the area should be.
Yeah, those are the properties of PDF. That's also fine. And we will get the area as 1 in this case.
Okay, wait, I'll check it once. I will discuss it in the end. Okay. I have to think for this.
Okay, fine.
So
Yeah,
can
we'll discuss for sure in the end.
Fine. Okay.
Yeah.
So can we go to activity 4?
No issues. That's fine. Sure.
Yeah.
So 4.3.
Sir, I think it is a functional value.
Yeah, this is a. But
so suppose we are taking from 0 to 0.2.
Yeah.
So the area will be 0.2 into 2. So it is always less than 1.
Yeah, that is fine. Every if you have to calculate the probability till x is equal to 0.2, so we'll get the probability.
So it doesn't matter the height. It can be 5, 4, anything. We're finding the probability in the close little interval. I think close interval, sir.
See, what I was asking. See, why CDF can't cross 1, so everybody would be winning, because till
CDF can be beyond 1.
Yeah, because till that point we have to do the summation of all those points.
Summation can be beyond 1.
Yeah. So in PDF, how generally we calculate the probability of in the PDF? If we have been given some continuous PDF, we calculate the, say, for example, this 2 generally here is not representing the probability at that point. Okay.
Yes, sir.
So you have to, if you have to calculate, see, for example, if you have to calculate.
You have to calculate. It is the functional value only.
Yeah. So if you have to calculate the probability greater than x 0.2, then what you will do, you just have to calculate the area to get the probability. You just don't have to see for those values what's the functional value at that point. Okay.
Yes, sir. I was saying the same thing.
Yeah. Have you got the point, Apul?
Yes, I got it. So, sir, can we say, I mean, in order to come to some conclusion, the graph is not the stopping point. We have to go forward, and looking just at this thing, 2 or any value, I mean, not hung up at 2, but 2, 3, 4, whatever is the value, that does not make any sense.
Yeah, the value can be anything. You just have to see whether the area is coming 1, and while calculating probability, you just have to calculate the area to get the
so no interpretation can be just derived from looking at this 4th graph, bottom right.
Yeah. No interpretation means?
One interpretation is being done from this is uniform, because there is no
it's just a height of uniform distribution.
Yeah, this is just a height. It is just showing
so
the
only only uniform distribution can be interpreted, but again relevant values between
only uniform distribution it can be interpreted. And the what in the lecture it has been mentioned for the, I think, uniformity of that only.
So, Vishal, again from this particular perspective, between 0 and 0.5, it will be the same formula 1 upon 0.5 minus 0.
Yeah.
And that will give the probability of any value lying between 0 to 0.5, right?
Yeah, correct.
Okay.
So can we move on to activity 4.5 and 8th question?
Yeah, I have a question regarding this. Can I ask?
Yeah.
I always thought that PDF and probability were the same. They are not?
What?
PDF and probability, they are the same. They are not?
No. From the PDF, 1 upon b minus a.
How is probability of a probability of x taking a particular value and a PDF is different?
It will be, see, 1 upon b minus a would be the function, like the probability value. low. See, 1 upon b minus a. What is that b minus a? Can you repeat that? What you were asking? The probability, PDF, and
No, I always thought that probability and PDF are the same.
okay, you are asking always. You always thought probability density function and probability is same.
Yeah.
But
Was that
variable
wrong?
is-
Was this understanding wrong then?
Yeah. Seriously. Okay. I also considered every time same, but
No, Anirban, it is not right. PDF and probability are not the same. And what Vishal has just explained, and there is a lecture that professor says, when you are looking at PDF, probability density function, the probability will be per unit length. Per unit length will come out to be probability. ये मेरा doubt था विशाल, which I wanted to ask what exactly is per unit length, but once you have explained, it is clear. The probability is per unit length, which can be derived from PDF. Per unit length means 1 upon b minus a, what it was just clarified right now. So that is how you
Okay.
will get the probability, again between some interval, not at a particular point for continuous. This is what I understood. Vishal, please correct me if anything wrong
yeah,
is
no,
what I have
it's fine.
interpreted.
It's fine. You just have to calculate the probability.
It has been mentioned in the lecture also. W is the width of the PDF and divided by b minus a. This is the probability. Whenever we want to calculate the probability, W divided by b minus a. W
Yeah,
is the
you just have to calculate the width of this and then multiply
divided
with
by
the height.
b minus a. B minus a is the height.
And that was my question. Nothing from the graph itself can be seen, but yeah, you have to do some calculations further to derive the probability.
Yeah, and if this is the width, the probability would be from 0 to this one would
B
be the
minus-
height into the width of this.
W by b minus a.
Yeah, W by B minus A.
This is the formula given by the professor, and W where W is a parameter for width, and B and A are the upper and lower limits.
Yeah. Maybe.
But the question is that, sir, whether we can use this directly without going to the graph or making calculations.
Yeah, for discrete is a PMF. Yeah. What? Repeat that.
Whether we can use this formula W upon B by A for calculating any probability without going to the graph, because width is nothing. Width without a graph you cannot calculate the width.
See, if you are having some sort of uniform random variable, some sort of things, right? This is A and B.
Yeah, I understand, sir. Here we can do. If there is
So
no,
if you have to calculate the probability from there, this is A plus E till B minus E. You just have to, you have the height, right? You just have to calculate the area.
Okay.
Got it? If you have to find the probability of X, A plus some C till A plus C, so what you will do? You'll just calculate the area of this one.
yeah. Width will be A plus C minus A, C divided by B minus A.
Yeah. So every time you have to do. So that is what has been discussed. This is a
fine. Thank you.
Yeah.
Through an activity 4.5, fifth one.
Activity 4.5. Question number 1. Which one? Question number 1.
5.
So the probability, the PDF
There
of the
to
function.
find the value of C.
So C, you can do, just do the summation and that equals to 1. So you'll get C, right?
The CX, we will get CX only.
Just do the integration like from
0.6.
So if you will do the summation from your probability, your function is 0.1 from 0 to 1, right? Your function is Cx from 1 to 2. So do the integration here. So if you will do the integration, what you'll get? So you are having from 0 to 1, your function is some sort of 0.1. And then from 1 to 2, you just do the integration of cx, dx plus point till 3 means 0.1 into 1 plus 3 minus 2 into 0.3 and equate to 1, you'll get value of c, right?
So 3 minus how?
Which one? This one or this one?
The 3 minus 2.
So what is that? See, 3 till 3 minus 1, why I'm writing? Because from 2 to 3, our function is in the form of rectangle, right? Rectangle means the probability density function value is 0.3 from 0.2 to 3, right?
Yes, sir.
For example, I'm telling you
Here,
this.
here there is. Hello.
From 2 to 3, this value is 3.3, right? So what is the area?
0.3 into 1.
Right?
Means
Similarly, you'll calculate the area for this and
sir,
you can calculate the
it
area.
means it is uniform over 2 to 3.
You can say no. Yeah, you can say it's uniform. Not proper uniform. Again, you will say why not 3 minus 2. So it's not a proper uniform.
Okay.
So the
Sir,
8th one,
Yeah.
same on 8th.
Sir, in this case, this 5, I have one thing needs to be clarified. Sir, in this case, it can't be a CDF, right? Is there any way?
It's not a CDF. Yeah, it's not a CDF.
It can't be CDF. It is a PDF, but it can't be CDF, right?
No, it can't be CDF.
Yeah, like somebody asked, right? If it is a PDF, it is going to be definitely CDF, right? In this case, it is failing, right?
No. She was asking some different thing. She was asking if something is like for example, this has been defined, this function PDF. So for this function, for this PDF, there will be some other CDF, right? Some valid CDF. This is what she was telling. If you are having some valid PDFs, you will be having some valid CDF also. So one PDF can't work as both PDF and CDFs.
Okay.
One function can't work as both like PDF and CDF. If some functions are there as a form of PDF, so after integrating, we'll get some CDF and that will be also valid. This is what she was asking. She was telling. Any other question from this one?
No.
One question from question number 2, sir.
Yeah.
Okay. Sir, in this question, I think option 4 is also right.
Which of the following is correct?
Fx is always a non-decreasing function.
This is asking about the PDF, not CDF.
But the PDF is also a non-decreasing function. No?
Who told you? It can be increasing also, right?
So as per the property number 1, fx is greater than equals to 0.
Okay, see. So what generally we need for the PDF? We generally need that the PDF should, the value, the integration of that PDF should be 1, nothing else, right? The PDF.
Yes, sir. Yes, sir.
So if you are having some triangular function also that is increasing. So the area can come, like we can adjust the value of this x. So we can have this sort of PDF, right? So from 0 to some sort of this value. What is the value? 1 by 2 into AB is equals to 1. We have to get. Okay. So A, we can adjust some value. Like we can adjust this as 1. And this we can adjust at 2. So this can be 2 and this can be 1. Okay. So this is an increasing one, but the area is 1, right?
Yes, sir.
So this can be a valid one, but it's not a decreasing function. It's increasing.
So it is given that fx is always a non-decreasing function. Means fx is can be an increasing function or can be a constant function. It can take a particular value.
Okay,
for
then
some...
take this one. That is fine now. Here also the area is 1, right?
Yes, sir.
So this is correct. This is not correct.
But sir, what is the significance of this thing? Like fx is greater than equals to 0 then?
Fx is greater than equals to
0.
Fx is greater than equals to 0 means every time the probability value is greater than equals to
Probability is always positive. It is not negative.
Okay, sir. Okay,
Yeah,
thank
this is
you.
a fundamental rule.
Yeah, okay.
So 8.
Sir, I have doubt in third question.
Okay, third one.
Yes, sir. Why it is not a PDF?
Just do the integration, see the value of area.
Sir, I have got the value of area is equal to 1.
4 by 15 x to the power 4 upon 4 minus 1 to 2. One second.
Sir,
Yeah.
when we put the value of -1, it will go negative.
So, yeah. So if we'll put the value of 2 here, what's the value of 2 here? 2 to the power 16, right?
It becomes 17 by 15.
And then minus of -1 to the power 4. 115. The area is 1, right? Okay.
Sir, when we put the value -1 in function, then we get negative value. So
yeah. This can't be it. Yeah. If you put the value x something like -1 or -2 point minus 0.5, you'll get some negative value. So probability can't be negative, right?
Okay, sir, I have got it.
So can you explain question number 6 of the same activity?
Question number 6, right?
Yes, sir.
So here the PDF has been given of a random variable. Now you have to calculate what's the support of x. Support of x means simply the range, right?
So why it can't be 0, 1, whereas 1 is included in the range? It is also having the positive probability, no?
Why it can't be 1, you're asking?
Yes, sir.
So in this function, 1 is not been defined, right?
Yes.
Okay, x is not taking 1.
Okay, sir. Okay, thank you, sir. I didn't just looked this much here. Fine, sir.
Sir, 8. In this, k is equal to 1, right?
This one, 8th one.
No, sir. Yes, sir. The same question follows that kx and 1. In that k is equal to 1, right?
No, k is coming to be 2.
2.
That you can do the sum. Yeah. What is that? Kx, right?
Yes, sir.
0 to 1 you have to do. So k by 2. So k is 2. So what's the problem in this? 0.5. So till 0.5 you can do the integration, right? Now you can do, or you can do, right? What is that? 2x. And you can do the integration from what? What was the value? 1 to 0.5.
Yes, sir. Understood.
Got it, right?
Yes, sir. Sir, in the C, fifth question, sir. C is coming to be 0.4 here.
Here.
Yes, sir. C is coming to be 0.4. So the Probability function is 0.1, 0.4x, and 0.3, right?
Yeah.
So for 1 to 2.5, we have to integrate 0.4 into x plus 0.3.
You have to integrate from 0.4x. You have to, if you are getting 0.4, so you just have to integrate from 1 to 2 this one, and from 2 to 2.5 means 0.5 into 0.3, that is 0.15 that you have to add. Okay.
So why we have to subtract 2.5 and 2?
This is what you are doing. 0.3 into 2.5 minus 2, that is 0.5, plus do this integration from 1 to 2, you'll get the probability value.
Yes, sir. Okay.
Yeah.
Excuse me, sir.
Yeah.
So what is the usual criteria for checking support of x? Do we have to put random values of x and then we'll have to check for what values of x we are getting the probabilities to be positive?
Yeah, for which and all values probabilities are possible.
So, sir, hit and trial method is considered here for support of x?
Yeah, nothing else. Yeah.
Okay, okay, sir.
So we'll go to the next one. Do you have any problem in activity 4.6? Anybody? All of them are formula based, I guess, mostly, right? Excuse me. 4.6, anybody is having any issue in this 4.2, 4.6? Everybody has seen the lectures, right? All the lectures?
Yes, sir.
Yeah, seen, sir. One last
No,
one.
sir.
Last
Not
one left.
yet.
Last
No,
one.
sir, not yet.
Last one left.
Okay, last one left. 4 point, I guess there will be problem in 4.7 and 4.7 only, I guess. Till 4.6, there won't be any issue. So do you have any issue in 4.6?
4.6. Normal distribution is important.
A simple one. These are all simple: uniform, and then uniform,
No.
normal, exponential,
That is
exponential. So you don't be having any problem in this equation. Just you have to convert this in the standard form. So you just have to write like 45 minus
mu upon 2 sigma square is the conversion, right?
just convert it in the form of standard normal distribution. So converting means like x minus mu upon sigma you have to do, and you'll get in the form.
Everywhere it will x minus mu upon 2
Whenever they're asking you in the form of fz, you just have to convert that in form of normal distribution.
Okay.
So
now,
no issue with this.
Sir, one question in that: how the formula that 1 upon sigma under 2 pi into e to the power minus x minus mu square upon 2 sigma square? We have to remember it, or it is?
I just remember
Sigma, 2 pi into e to the power minus x minus mu upon 2 sigma square. This
so you'll remember. No, you'll not.
Have to remember it.
After writing 2-3 times, you'll able to remember that.
Okay, we have to remember.
In the exam, you'll get the formula sheet.
Okay, but derivation is not required to know, right?
No, nothing.
Okay.
Sir, did you say we'll get the formulas in exam?
Most probably, but I need to confirm. Last year, the student got. I don't know about this term.
What formulas will be there?
What formula? What is the extent?
Formulas, whatever is there in our courses, will be there.
Can we get a copy last year what was given, so that at least we know up to what level it will be there?
I need to check that once. So I'm not sure whether you'll be getting this. Till last year, everyone was like, we were giving, but I need to ask once whether we are providing that. But most probably you'll be getting the formula set.
Okay, the only
formula set means like all the formulas would be written there.
No, that's perfect. The only thing is if you decide to share it, then in that case, can it be shared a priori so that we know to what extent it is going to be shared? So then we will not.
Yeah, he's absolutely right. We should know so that at the first instance we should not be surprised what they have given.
Yeah, I can't find it now, but it's there somewhere. I need to check it.
Sir, do you mean
if it is possible, sir, please upload in the supplementary content.
So what I'm asking is, will I get a list of all the formulas that is required, or by question wise, right? In that question, which formulas I'll require, and I'll
No,
get
no, not that.
Of course not. Yeah, that's right. Right.
That will be a hint.
Yeah.
Okay, I don't know where is that, but yeah, I can't find it now. Okay,
anyway,
but
no, if you can find it out later on, if it decided at this time also it will be shared. In that case, you may please upload it on the supplementary. That will be helpful.
Yeah.
Sir, if it is part of supplementary content, other in the discourse course, anywhere you just share it, we will do it.
You mean formula by like mean of uniform distribution?
Yeah, everything.
Expectation of variance of uniform distribution, like that, right?
Yeah. Everything.
Got it.
So this 4.6, you don't have any problem, right?
So sir, in the lecture there is one doubt.
Okay. Even I have not seen the lecture.
Sir, lecture में एक formula ही है, maybe not the whole lecture, but just the formula you might want to take up.
Okay, where?
Sir, 16.48.
Okay, 16.48, right? Where?
Right. So sir, थोड़ा सा 5 seconds more. Yeah, so the general formula that is coming over here, Px greater than s plus t, given x is greater than s, we have got over here e minus t.
I think it's mistake, I guess.
Should it not be e minus e raised to power minus 2t?
If
you just look the
lambda s should be the value, lambda t. Lambda is not written here. Where is the value of lambda here?
Okay.
2. So lambda is missing. So,
yeah, so lambda is missing, right? Fine.
Yeah.
Clarifies. That was my doubt. It is not e raised to power minus t, but 2. But you are saying lambda. Okay. Thank you.
Lambda should be
fine.
there.
Thank you. E raised to power minus lambda t. Fine. Thank you.
So 4.6, you don't have any doubt. 4.7. I guess after 4.6 nobody has solved, or what? 4.7 people ask so many doubts in this.
No, sir, didn't solve.
We haven't got time this time around to go through it so fast.
Okay.
Their lectures are more in this week in stats.
Yeah, yesterday only our submission. Yesterday, no, I think Wednesday was our submission date.
Okay.
After that, as such, some of us haven't got time. Some of us have gone through it. Some of us haven't got time. Generally, we go through it on weekends. People who are working.
Okay. So
we can proceed. We will pick it up.
So, is it necessary to go through the lectures?
For 4.7, you have to. 4.7, 4.8, 8 is not that important, but 4.7 you have
not
to.
gone through the 4.7, so I think.
Yeah, 4.7 you should watch. That is of around 45 to 50 minutes, and that is very helpful.
Yeah, we will discuss it next time. So most of the people, I think, have not gone to the 4.7. I think your time will also be wasted. We can discuss other things also.
Yeah. So what do you want to discuss now?
Anything, if anybody has the problem, because 4.7.
So if you don't have any problem, 4.7, I guess many of you will face the issue.
Okay.
Sir, can you solve first question 4.7?
It is better to give the key points.
So the first one is a pretty simple one. But not first one you'll face the problem. Not in first one. You'll face the problem in second, third, maybe. Not second one also is simple. Yeah, third one you'll face problem, and then fourth one. Other than that, fifth is simple. And So this in this 4.7 generally, sir has discussed. See, if you are having some, if you have been given some PDF of x, okay, and then has defined some PDF of x square. Okay, so if we are having some PDF of some sort of random variable x, and the function of that x has been defined, I'll just tell you the brief. Maybe if you'll go through the lectures.
Better to discuss the key points on.
Sir, can you continue, sir?
Yeah. You're asking something?
No, sir. If a PDF of a function is defined on a PDF, then how to proceed? Like, what's the algorithm?
So if you have been given some PDF of x, and they have defined some y as x square, not x square. I'm just first I'm taking some simple equations. So why they have defined some function that is monotonically increasing or decreasing.
Monotonic function.
So, and now they have told you to find the PDF of y. So you have been given x, but you have been told to find the PDF of y. So for that, you have simply one formula for that has been discussed in the lectures. That formula is also very useful, but the thing is, whenever you will not get anything like any functions like that generally is increases or decreases. For example, x square, I was telling you in the starting, x square generally increases from 0 to infinity, and then from minus infinity to 0 it is decreasing. So okay, so this will not come under this our category. So whenever we'll be having monotonically increasing or decreasing function, this sort of function, so you'll be having a simple formula of that. So whatever the PDF we were having, so PDF of f, in spite of x here, you'll write g inverse of y, okay, upon mod of, you'll take the differentiation g dash, and in spite of again x, you'll write g inverse of y. Okay, so this will be the fy of y. So this is the PDF of y. Okay, so this was the example. This was the one equations we'll be getting in this 4.7. This is the one of the pretty, like whenever you'll get any equations like x cube you have got. So x cube you can directly do that. You can get the g inverse y also. G inverse y you can get it like if you are having y is equal to some sort of I'll tell you from the basic, like one question, like for example, if you have been given x has been given, random PDF of x has been given. Okay, PDF of x has been given, and y has been defined as ax plus b. So how you can write the g inverse of x? Okay, so what you will do? So just put here we are having y at one side, so just try to put x in one side. So how you can put y minus b upon
a
is x. Okay, so this is generally the g inverse of x, g inverse of y you can say. So g inverse of y is what? Y minus b upon a. Okay, so g inverse of y we have got. What was the formula that we have got? What the formula to find if we have been told to find the PDF of y? How can we find the PDF of y? Can we find because the PDF of x has been given. Of x here we have to write, but x, how we have to replace this x with g inverse of y? So what is that? Z f minus b by a, right? So similarly, we have to take the differentiation of y. So what is the differentiation of z dash x? Z dash the differentiation of this function g, right?
Yes, sir.
So what we can write? 1 second. So if we'll do the differentiation of this function,
1 by
no, this A.
Okay. Differentiation of y. Y upon dx.
Okay, I'll confirm in the lecture is that whether we are taking the differentiation of that g directly or g inverse x.
dy.
Yeah. So what we are doing, we are just taking the if we have been given x, okay, like the PDF of x has been given and g dash of x is defined. G dash of gx is simply the whatever the function new function has been defined, right? Y is equal to z of x. Okay. So what we'll do, we have to check whether the derivative of gx is possible or not. Okay, and that the function is monotonic. Gx should be monotonic. That is the only one condition. If that gx is monotonous, we can directly apply this formula. Other than that, like if your equations like mod x is not like always monotonic, because this mod x is also like from minus infinity to it will come to 0 and then go from 0 to infinity. Okay, or you are having x squared, so some sort of things like that. So you won't be able to apply this formula. Other than that, for most of the cases, you'll be able to apply the formula. So what you can write it directly, if you are having some sort of y is equal to x plus a or y is equal to a, what you can do, if you will do the differentiation of this y, you'll be having y is equal to ax. So similarly, you can write a directly here. So this will be the PDF of y. Okay, if you have been given x already, and you have to calculate the PDF of y, where y is ax plus b. Okay, this is the one of the important concept, like one of the important formula that you will read in this lecture. And then the next part would be, so this was the part, so this and all you can just go through once. So yeah, this is the problem. But see, but if you have been given some function where see x square, but for in this case it's monotonically increasing, because for exponential function this has been this generally is defined from 0 to infinity, right? So this will work here, but not for all other cases. But this, for this case, it will not work. Our formula will not work for this cases, because here what is the x square? X square is here will come from minus infinity to 0 and then will go from 0 to infinity. Okay, and our uniform distribution has been defined from -3 to 1. Okay, so this will not work. The formula will not work here for us. So for what we will be doing here, for those equations, if we have been given gx and this is not monotonically increasing or decreasing or sort of equations, so what we will do, so you will just try. So how generally we calculate f of y? If we have been given x, fx of x, the distribution of x has been given, and we have been given a y in the form of x. So how you will calculate the distribution CDF of y? So there are generally 3 steps to calculate. First, you should calculate the support of y. Then calculate the CDF. Then calculate the PDF. PDF can be calculated directly by differentiating that PDF. Okay, so here you can find directly. Yeah, so if that function is not in our condition, like not satisfying our conditions, so what you can do, you can write like this. This is what the CDF is. Now you can write that y in the form of gx. And now you have to find all the conditions, all the values of x for which it's less than equals to y. And from, because you already have the distribution of x, so now you can calculate with the help of distribution of x for all the values of x where x is less than equal to y. You can calculate the probability and can get the CDF of y. See, I have just told you, but this is not that simple to calculate. If you will try 1-2 questions you can try with the help of formula, you'll be able to directly track that. But when it comes for when you will be having when you will be given x is equal to y is equal to x square, you won't be able to solve that, because for that cases what you have to write, you have to write in the form of this one, probability of x square less than equals to y, right? So now what you can write, probability of x is less than equal to minus root of y to root of y. Okay, and now you have to see, and now you have to compare whether the support of this y. So what you can, for example, I'm telling you, if you have been given x as a uniform distribution from -3 to 3, okay, so this is what -3 to 3. So what will be the x square here? X square will lie from 0 to 9, right? Got it? This is what y is. So if we have to get, because our formula won't work here, our formula won't work because our formula generally perform whenever there is a simple equation, simple functions, like that is simply some increasing or decreasing function, but here it's not happening for us. So what we will do, we'll approach from the basic thing. How generally we approach as a basic, we generally will write how to calculate the CDF of how generally we calculate the CDF of y. We'll calculate the CDF of y, we'll just write, okay, CDF of y, f capital Fy is generally probability when capital Y is less than equal to y. Capital Y is what? X square. So if we'll write in the form of x, y, and now we have to write it in the form of x, because x, for x we already have the distribution. For x we'll write, so here x will lie between minus root y to root y. Yeah, so what I told you in the starting, the three things you should be very much clear whenever you'll get the question. One thing is, if you are having the function as monotonically increasing or decreasing, just apply the formula. You don't have to do anything. If you don't have that equations in your favor, then you have to apply this equation. For this equation, you have to just get the support of x. Support of x is what? -3 to 3. Support of y is what? 0 to 3. Now you have to see, okay, so probability in the form, if you have to calculate the CDF of y, that has came down to this one. Okay, that means probability of x should be greater than equal to minus of root y and less than equal to plus root y. Okay, so what's the value of that? And what is the value of minus root y and root y? So if y varies from 0 to 9, so minus root y will vary from what? 0 to -3, right? -3 to 0. Okay, so and plus y root will vary from 0 to 3. So both these value are coming under our support of x. So one thing you should be very clear, when this is the support of y and this is support of x. So your support of y should come under support of x. If that is totally coming under the support of x, then you can directly write. So this is what? This can be value of root y and this can be the value of y, right? Because support of y generally comes under the support of x. So what you can do, you can calculate the area. So x, what would be the area of that? So root y upon root y, what is that? 2 root y upon 6. Okay, so this is the PDF of y. Have you got the point? Like whatever I've explained you till now.
So the support is root y. The support is the interval, na sir? It should be interval of y, na, or root y.
See,
how to calculate the support here?
See, what was that x? X was uniform from -3 to
-3 to 3.
Y was x square.
Yeah, 0 to 9.
The x is 0 to 9. This is the support of y.
Got it, sir. Got it. Oh yeah. Mod. Okay. That will be mod y, right? Yeah.
Okay. So and then you have to find. So similarly, if you have been given, so there are some questions where you'll be given uniform from -3 to 1 or -3 to 2, and then you have to calculate. So what you will do at that time? Okay, if you have been given -3 to 2, so for that, if you have been given 1 is equal to mod x, if you have been given. So mod x is also not monotonically increasing or decreasing. You can't use directly the formula. So what you have to do, you have to go from the basic approach. You will just write it in the form of capital Y is less than equal to X. Sorry, capital Y is less than equal to Y for the CDF of Y. Okay. And now you can directly write it as mod of X less than equal to Y. Okay.
Yeah.
Similarly, you can write it as in the form of X lies between minus of
minus
Y
A to Y.
Okay. Now you will check that. Okay. What was the support for Y? What was the support for Y? That was 0 to 3.
Minus 3 to 2.
No, Y is mod of X. So
Okay.
if you will take the mod of X
Yeah,
value,
yeah.
your support will be 0 to 3. Okay. So now if you will check whether all the values are lying between the support of X or not. So you will see from 0 to 2 it will lie, right? But 2 to 3 is not lying.
How is this 0 to 3, sir? Support of Y? How is 0 to 3?
So if you will take all the values, see, this is X.
Yeah.
Okay. This is X. So if you will just take the values of all X, like for X, X was minus 3.
Minus 3, minus 2, minus 1.
Okay, minus 3, minus 2, minus
1, 0, 1, 2.
So all and between also there will be values. Okay.
Okay.
Just see for minus 3. If you will see minus 3 of mod of minus 3 is what? 3.
3.
Okay. Mod of minus 2 is 2. So 2 will come. I written 0 to 3. Similarly, till 0 to 3, all the values will come.
Yeah.
Okay. So now what you will do here? So here you will what you will do? Here minus from minus, see 0 to 3 means what? Minus 3 to 3. But minus 3 to 3. But minus 3 to but here minus all the minus 0 to 2 is coming, but 2 to 3 is not coming inside that support of Y, right? If you see, if that was minus 3 to 3, so there was no difficulty in this solving. There was no difficulty in solving this question.
Yeah.
You can directly write it like 2y upon 6. Okay. But here you don't have that. You don't have. You were having already minus 3 to 2. So till you just have now you have to break this into two set. When first is 1 0 belongs to y belongs to 0 to 2. Okay, and then y belongs to 2 to 3, and then you need to solve. So 0 to 2 you can directly solve.
Yeah.
Okay, and from 0 to 3 you have to solve. You have to check the support.
2 to 3.
And then you have to check the support of X and Y. So I don't know how much you have not seen the lecture. That's why many of you are not asking the doubt. But if you see the lecture once, maybe it will be more clear to you. And then we can discuss.
Which lecture is this?
4.7.
Last one.
Okay, thank you.
Yeah, so what I was trying to tell you, you just go through the lecture, and then if you are facing any doubt, you can just put it in the discourse, or next maybe the next live session, that is the office hour session, we can just give 1 or 2 hours for this because many of you will be facing the problem. I am pretty sure about that.
Yes, sir. We will make some exercises before that so that we would be clear.
Yeah, so just go through the 4.7, 4.8 on, but most of the things except 4.7 is pretty simple. You won't be facing any problem, and those doubts were not that difficult also. Everyone will be able to solve the questions, but just go to the 4.7, try to solve all the questions. Go to the tutorial second also, that is tutorial second or fourth week. Just try to solve and just go through the solutions also. You will face many problem in that.
Sir, excuse me.
Yeah.
Solve with instructor slide for week 2 and week 3 hasn't been uploaded, sir. When can I
Okay,
get
then
the slides?
I'll tell them to upload it today or tomorrow. So that will
Thank
be
you. Thank you.
tomorrow. Yeah. Okay. So okay, then you don't have any doubts now, right?
Only Sunday is the sir assignment date. How it will be managed? Only 2 days is left.
Oh, which assignment? Fourth week?
Yeah.
Oh, okay.
They have preponed. Why they have preponed? We do not understand at all.
Earlier, what was the date?
Earlier was Wednesday.
Okay, so now you need to submit it by Sunday itself.
Yeah. How it will be possible?
Okay, then I'll just tell them once. Yeah, many of the students have not seen the lecture till now.
Yeah, it is better, sir. It's better to
Rationale was discussed in the last discussion over there that since quiz 1 is approaching, there is a refresher that would be required across all weeks. That's why this week submission has been preponed. And 5 submissions out of 8 submission, best 5 out of 8 submissions will be considered for the final grading.
Yeah,
so people can give more importance to the quiz 1. That's why it has been preponed.
Yeah, is it 5 out of 8 or 5 out of 9?
5 out of 8, 5 out of 9, whatever. That day also it was a confusion. But the quiz 1 is obviously more important than the individual assignments.
I think it is 5 out of 9, and for the bonus marks it is 7 out of 10 or 7 out of 12.
But anyways, the quiz 1 is the
It
rational.
was 6 out of 9 earlier, but one paper doesn't have a assignment submission, so that is why 5 out of 8 for last term, because one of the papers they cancelled, so that's why it became 5 out of 8, but it's actually 6 out of 9.
No, the document, I think it says 5 out of 9. If I remember correctly, we need to recheck.
Yeah, actually one of the papers in stat 1 was cancelled actually last time. That's why the document says that.
Yeah, last time this was the case. He's telling right. That's why, because one question, one assignment
5 out of 8 last
having a
time.
number of wrong answers or questions.
Yeah,
Like
it's just fine. Like, yeah, it should be, I guess, 6C doesn't have assignment. Yeah.
What I'm asking is, for us, for this particular batch, there was a document. Now, in that document, I think it is 5 out of 9.
Okay. Okay, then it should be 5 out of 9 one day, I guess.
Yeah. And for bonus marks, it is 7 out of 12, I think. No.
Okay. Yeah, those things, I guess, will be there in the portal or somewhere. Yeah, on the portal it should be there.
yeah, it is mentioned, sir. It is all the I think plan has been mentioned in the student notebook, already given in the dashboard.
Yeah. So what you can do, so I'll just inform you regarding the solvent instructor, and one thing is the formula set. Okay. Nothing is
Formulas. Yes, sir. Formula set is required.
And one thing you can do, if you are preparing for quiz also, so 4.7 is an important thing. Okay, important topic.
Okay.
So there will be question from 4.7. So,
okay. We will make an exercises, good exercise.
Just go through that. If you are having doubts, so just ask me. We ask on the discourse. If you are having, for Pakka, it will be problem for you. But yeah, we can discuss it in some office or in the revision session. We can discuss again for 1 hour. After, if you'll watch the video, then it will be like, it will be better for you. You'll be grasping more. Other than that, I think it's fine. And yeah, so now we can close the session, right? Or you are having any doubt?
Before the quiz, will there be one? There will be a mock test, right?
Yeah, there will be some mock questions will be given to you. I'll tell you, mock, just try that mock also. Like, try to solve that mock. Try to solve all the assignments at least 2-3 times. Most of the concepts will be very similar to that. I can guarantee you.
Sir, one thing, collab is also there in the lecture. One last lesson is collab.
Yeah, the collab won't be asked in the exam.
That will not be asked.
No. Related to collab, there won't be any question.
Okay. But one thing, one code I uploaded in the collab, it did not execute. It took a long time, I think. So how to operate the collab, we are not acquainted with that, because we are not from the programming side people.
No, you are asking for the extra activity 3 week 0. That is what you are telling.
The extra activity is including the collab, but independently, collab is also not. We are not understanding how to update collab. In the last session, I asked that they were, IPython will work better in collab. Then I went with a code and uploaded in that, so that because that's why I could not do that extra activity.
The best thing you can do is you have already completed Python for data science.
No, parallel.
Okay, that is going parallel. Okay, that could be the issue you are facing actually. But the best
that's why because Python is also I'm learning, and the parallel is the same collab is also there. So something is if you miss there.
Collab, then what you do, you just take it as simple like you are using Replit, no?
Yeah, I'm using Replit, and in the last session in the Python office hours, they told the collab is better. Then I went to the collab. What happened? A code I shared also in the discourse also. That collab, when I put that code, then collab hanged. It was just working, executing one by one like that. How it was working, I was not getting the result.
That could be some you might have entered into some infinite loop or something like that. That if
maybe, but because I'm not totally mastered in Python also.
The best thing what I'm trying to tell you is that you use it as a Replit actually, like the way Replit is being used, simple codes.
But in the extra activity, they are telling that give a code and explanation and everything upload in that collab.
That itself for that sample code also is given. No, sample code is already given. So if you are facing problem, you can just put that code as it is and run it. That's it.
I think there is a video on.
I gone through that video. That video is not working properly. That is
maybe you would have went into some loop or some sort of infinite loop.
Maybe I was not aware of that. That's why I asked you what to do exactly. There are some people who have done it, how to coordinate with that.
Yeah, if you have some basic doubt, I can help you.
Okay, then how can I contact you? Share your email ID in the chat. I will share my problems.
It is 21F 1003506.
Just a minute. 21F
1003506.
1003506.
Yeah.
1003506.
Yeah.
Okay.
Excuse me, sir, Vishal.
Thank you.
Sir, I have a doubt on
your good name?
Exponential distribution.
Anwar.
Thank you.
Sir, I have a doubt on exponential. Yes, sir. In that, sir has explained that P of x greater than s plus t given s greater than s.
Yeah.
Yes,
okay,
sir.
that was
e power minus 2t, right?
Yeah, that should be lambda t. Maybe that error or that just a typo error or writing mistake.
Okay, so whichever lambda it takes, it will.
Yeah.
Yes, sir. What is the exact difference between PDF and CDF, sir?
PDF is simply what we can write.
So what it describes, PDF describes that the density, like that, how many people have taken that or something like that.
Yeah, some sort of density probability in the form of
what
density.
CDF says.
So CDF will just tell you till this point. Like, if this is a plot of CDF, okay. So CDF will tell you till this point. For example, this is some random x. So till this point, what was the probability till this point? So the summation of that PDF till that point, that will be represented in the form of CDF. Okay.
The best thing I think is to understand from that English word itself. The way you say cumulative itself mean
the addition of all those probability.
Yeah.
Okay, sir. Okay.
Yeah. So yeah, there are some people saying there are. Yeah. Thank you. Thanks a lot.
Thank you very much, sir.
Yeah. Thank you.
Next time you will be prepared. That
one more thing, sir, that on that quiz, before the quiz, normally we used to have certain priority list and important topics to be noticed, those kind of sessions. Those will be done when exactly?
The date will be announced to you. Like the session, the revision session will be there. In that revision session only they'll tell you. If I am taking, I'll tell you the.
For many of us are working people, prior information.
Yeah, there will be prior information. Like in coming 2-3 days, you'll be getting.
Yeah. Okay.
Yeah, so in upcoming 2-3 days, you'll get to know about it.
Right.
I have a specific question about
The date will be announced.
assignments. Can I ask?
Yeah.
Yeah, basically, let me start with this way. For us working professionals, I'm yet to watch the week 4 lectures, right? And the deadline is Sunday. So is there
Can you
any
please mute,
route
like
map?
everybody else can mute that?
I have a specific question about assignments. Yeah, can I continue?
Yeah.
Thank you. I hope that in my asking this question, others may get at the clearing also. My question is like, since the deadline is on Sunday, and there are a lot of us who haven't started on the week 4 lectures in stats 2. Is there any recommendations from your side as to how to go ahead about the next 1.5 days?
What you can do, you can watch the videos, you can skip the videos first and second. I'll check it once. What you can go. So if you don't have much time, so you can skip the first one. You can just briefly go to the second, briefly go to the second, like if that is of 10-25 minutes, you can just try to complete that in 15 to 20 minutes. You'll be able to do that. Third is also like you just have to, most of the concept you'll be already knowing how to change that discrete, not change, what is the discrete and continuous. The fourth, so I think so you can watch the fifth one, that is of 35 minutes, that you should watch. And then the sixth one also, the 5, 6, 7 you should watch. Yeah, 5, 6, 7 and 8th also you can watch. So this four videos you should watch.
Okay, and in terms of doing the tutorials or the weekly assignments, how should we do it? Like, should we do the tutorials first, weekly assignments in between videos? How do we do that? How do we get that?
After watching this video, just go to the tutorial first, okay? Then go to the tutorial third, and then the second one. Okay, first, third, and second. Try to solve the question. If you're not able to solve, just go to the solution. Okay, and then go to the practice. If you want to solve the graded, you can go to the graded directly. If you don't have time, because you'd have only 1 day or 2 days, right? So you can just watch 3, 4 videos. At least you should watch 4.6, 7, and 8. Okay, 8. After half of the video, you can skip. Like you can just go to the 2x speed. But 4.7 you should watch properly. If that is a 45 minutes, you should give at least 1 hour, 1.15 minutes. Okay. 7th video, 6th video also you'll be able to get after watching that with if you're watching with 1.5x also speed, you'll be able to catch up.
Okay.
Yeah.
Thank you.
And one additional information I can give you. I am also doing the same stat to this term. This last term people, the September term people, they have uploaded lot of notes actually.
That you can go. Yeah, that you can see. You can share.
Where are those notes?
Yeah.
So
where are those notes? How do we get access to those notes?
It is there, that link. I think somewhere I have to search in my mail. Somewhere it is there. It is all week wise. Everything is there. Notes are there. Then
Hello. I can share the link because this is open notes. I can share the link in the chat right now. Okay.
Yeah.
No. Can you share it in the Discourse, please?
Yeah, I will share in the Discourse.
Thank you so much.
Okay, open notes. You can search open notes. They're very simple.
Somebody has shared also, so you can just copy this.
I know. I have just taken the printout of that. They very good note somebody has prepared, and it is very helpful because that reference is very much required for the working people, because we are the working people, so we don't have right time to make a note of that.
Yeah, out of this, some they have done a very good job actually in explanations. I have seen that. I am mostly depending on this.
That's very good. That's very good. We should share it because we don't have time to write all the things. If it is there, somebody have made available, then that should be, I think, shared among the discourse also.
Right.
Or some
Sir, anything else from your end,
somewhere
or
we can share
leave?
it common portal. AB is
Vishal,
also
anything
having
else
a
from your
good
end, or
grasp
can
of
we
AB
leave?
is also having a good grasp on this. I think good questionnaire. AB is good questionnaire. If he gets something special, then he should share it. I will suggest. Are you listening, Apul?
Yes, yes, sir. I am listening, but I do not have anything special.
You
I
have a
am
good
just
questionnaire.
struggling.
You have a
No,
good
I am
news. I am
struggling
also
to read the
struggling, but
lectures.
your struggle helps me a lot.
That's kind of you. Thank you very
Because
much.
because I am also of the nature to go to the depth, go by the fundamentals. Don't. I think I am not as bothered about the scores, how much score I am getting. We must learn what we are learning. We should learn.
Sure. Vishal, anything else from your end, or can we leave?
Yeah, we can close the session now. So thank you, everyone.
Thank you, Vishal sir. Thank you.
Thank
Good
you,
night,
Vishal.
everybody.
Thank you, sir. Yeah, thank you.
Thank you.
Thank you, sir.